Hello. We are going to take one more look at distance time graphs, adding in one more piece. So our language objective for today is I can match distance time graphs on acceleration to situations using mini notes and two practice problems. So we're going to start with these mini notes, and I do promise they are actually mini notes this time. And then you're going to go ahead and try out a couple practice problems. So let's get going to set up your notes. All right, so you have already kind of set up these notes before. The only thing that is new, I'm going to highlight it for you. This used to say Mrs. Beadle's practice problem. I want you to just go ahead and draw in these new lines. So I'm going to give you two examples today with acceleration. We're going to take those notes there, and I'm going to leave the practice problems in your space down below. If you have lost this paper, feel free to just set up this part here, this half, this page we have already taken notes on. Oh, one last thing. If you have the ability to have a third color with you today, that would be great. So notice last time, remember I did blue for at rest and green for increasing or decreasing. Today I'm going to use yellow for acceleration. Okay, so just for a quick reminder that we use graphs because sometimes describing the motion of an object is hard to do with just words. So we're using a picture that can help us out. We have already covered, I'm going to highlight them in the colors we use since it's a little different. We've already covered stationary or at rest. We've covered constant motion, returning and back, and constant motion going up. Today we are going to talk about increasing or using acceleration, so getting faster, and slowing down, decreasing acceleration, negative acceleration. All right, so let's get to it. Okay, so we have already talked about increasing velocity going forward. We have already talked about objects at rest. We've talked about decreasing velocity going forward. We've talked about all the things going backwards. So let's go ahead and talk about acceleration now. Now, the easiest way to remember acceleration is I think of in a car. So when we are at a stop sign or a stoplight, when you push on the gas pedal, you are accelerating. You're getting to that point where you're going faster. And then your negative acceleration comes when you're stopping. So if you're coming up to a stoplight and it's changing from yellow to red, you're going to push on the brake and you're going to have that negative acceleration and slowing down. So the way that we draw this on a distance time graph is actually kind of a curve. So you can see, I'll point it out right here. That curve is showing acceleration, specifically positive acceleration, meaning going faster. So it's starting off maybe at a stoplight, and then it starts to go a little bit faster, and 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 a little bit faster, till we reach whatever the top speed is. So I'm going to go ahead and take a minute and graph that in my notebook. Go ahead and pause here for you to graph it as well. So once you've got that graphed, let's go ahead and talk about what this means. So one thing that this means, it means that we're increasing speed and going faster. So I'm going to write increasing, sorry, wrong pen, I was writing in my notes. Increasing speed bad handwriting. It also means going faster. Another thing that this means as we're graphing it is that our line is going to end up being kind of curved. So a curved line. But we're going to be a little bit more specific about this because if we are just talking about a curved line, I bet you could bet that negative acceleration is also going to be curved. So one way to think about it is that it is going to get steeper or less steep quickly. So if it's going faster, okay, it is going to get steeper faster. So imagine trying to run up this hill. Okay, notice how if you were a little person, do I have a little person touch point? No, we're going to pretend that this little red dot is a person. So imagine if I'm a person running up this hill. Okay, it's going to take a lot faster to get all the way up there. So increasing speed, the more it goes up here, the quicker it's going to accelerate. So then let's go ahead. I'm going to throw a video in here and we're going to see if we were right. Okay, so we just saw the car. I'm going to play it one more time. we just saw the car go from starting at 0, not moving at all, to increasing speed. Again, imagine if you're at a stoplight or a stop sign and you're increasing that speed until you've reached whatever your top speed is. So the last thing we have to do is we have to write it out as an example. So we can say that the little toy car, based on the movement that we saw here, okay, the toy car started not moving and it increased speed, or it accelerated, okay, until it reached the end. So we're going to make sure that we're using that word accelerated, and we're going to even go as far as to say it had positive acceleration, meaning it increased speed. So what I'm going to write is the toy car started to accelerate or increase speed until it reached the end. In this case, the end is literally just the end of the meter stick. I think it actually ran into a little other toy at the end there. Okay, so I'll read it one more time. The toy car started to accelerate or increase speed until it reached the end. All right, if you need to pause the video or rewind it to hear it again, go for it. I'm going to show you a picture of my notes now. Okay, so if you need to, here's a picture of my graph, what it means, and my example and my notes. I did go ahead and add in my color, in this case yellow, so that I am keeping that all consistent. And when we start breaking down hybrid graphs with acceleration, I have that in there as well. All right, let's go ahead and do one more type of acceleration. It is the opposite of positive acceleration. It is negative acceleration. Sorry, I know that was probably not super exciting on your end, but I had to switch like 5 screens, so it was pretty exciting on my end. So, with negative acceleration, we are seeing decreasing speed. So moving forward with decreasing speed, specifically on my chart, I'm going to highlight it in red for you. I'm looking at my graph. It looks like, okay, we are moving forward, but we are decreasing how fast we're going. Notice that this is a lot flatter. So one thing we can write about this, I'll actually start at the beginning, not get ahead of myself here. So we are decreasing speed. We're getting slower. Usually the slower ends up leading to a stop. So it goes sometimes to a stop. And then we are seeing a curve again. And notice how, this is what I was trying to say before I got ahead of myself. Notice how this line is a lot flatter. Our acceleration line, positive acceleration, looked like this. Okay, so we talked about its steepness. When you're looking and comparing the two, a negative acceleration line is going to be less steep. It's going to be flatter. And if you are comfortable with math, that would be a lower slope, lower number for your slope. Okay, so let's look at a video quick and see if we did this right. Again, if I'm going too fast for you, pause the video. Again, I'll show you my notes at the end. Take the time to catch yourself up if you need it. Okay, so let's see what happens. According to our graph, it should be moving forward still. It should be decreasing its speed though, kind of like it were to come to a stop sign or a red light. Okay, so from where we see it start, I'll play it one more time. From where we see it start, it starts to decrease its speed until it comes to a stop. All right, so let's go ahead and write this out in our notes. Jump back over. So what we can write is the toy car, good sentence starter, had negative acceleration. or slowed down until it reached the end. So I'll go ahead and say it one more time. The toy car had negative acceleration or slowed down until it reached the end. Now would be a good time, if you are doing colors along with me, to draw in your graph, add your colors, and I'm going to go ahead and show you my finalized notes. Okay, so here are my notes for positive and negative acceleration. If you need to pause the video here, go ahead, but we're going to go ahead and talk through a problem together as I am walking through the problem with you. You can divide that box on the bottom, and you can do one problem with me and one problem by yourself. By just dividing that box on the bottom, we're actually going to be drawing graphs. Okay, before we actually get into the problem, I'm going to go ahead and set up my paper down at the bottom, and we're going to need to draw in a little graph of our own. I'm just using pencil, and I'm using the lines as my guide. So I noticed that we have 1, 2, 3, 4, 5 boxes, so I can count five boxes down, then estimate 5 over. I'm just drawing it in with a pencil that's out of lead, and I'll show you a picture here quick before we get going. So, pro tip here, you can see my examples. If you draw the vertical lines first, the up and down lines, I'll show you these ones. Okay. If you draw those ones first, it makes your boxes a little bit more even. Yeah, pro tip. You can go ahead and draw problem 2 right now as well if you'd like, but let's go ahead and actually start looking at the problem. Okay, so let's go ahead and give this one a try. Our situation: Amelia accelerates during the 100-meter race and then stops at the finish line. Okay, so I am seeing accelerates during the 100-meter race, so that's going to tell me, okay, she's picking up speed, increasing, accelerating, and according to my cute little table over here, positive acceleration is going to look kind of like that, so that upwards curve. And then she stops at the finish line, and if I remember, at rest and stopping, that's my line up here. Okay, so if I draw this out, I'm going to start by drawing it in my regular black pen, and then I'll go over it with the colors to see how it goes. So I'm going to estimate. I know I need to have some time at the end to stop, so I'm just going to go ahead and leave that dot here, knowing that's where I need to accelerate to so that we can still stop at the end. So I start, and she accelerates during the 100-meter race and stops. So if I show you that with the color, she's accelerating. Oh my gosh, it changes the color of my pen. That's pretty cool. Accelerates, stop there, and then rests. Okay, so that's a really cool trick. I didn't know I could do that. I'm pretty pumped about that. But this is our example. So we have 2 different parts. Accelerates during the 100-meter race and then stops at the finish line. So we have an acceleration curve getting faster and then stops. Let's go ahead and try a problem of your own. Okay, so before we actually get to the question, I wanted to show you my example problem. I went ahead and wrote out all of the text because I know I am someone who will not just remember what the graph is saying if I just leave it like that. So yeah, there is my picture of what I'm doing to set it up. Now let's walk through the problem and see what it says to do. All right, so I want you to try this one. Our situation is James walks to the top of a hill at a constant speed and then stops. He then accelerates down the hill and stops at the bottom. All right, so we know that he is walking to the top at a constant speed, and then he stops. Then he accelerates down the hill, and then he stops at the bottom. All right, so I'm asking you to draw this grid out on your practice problem and show me what you think this graph looks like. So I noticed that there are 4 different instances here, so you're going to have 4 different segments of that graph. This might seem kind of like a challenge problem. This is the first time I've had you draw a complex hybrid graph of your own. If you are incorrect, that's okay. I'm really trying to see what you know and what you don't, as we're going to move into another real life lab where you're going to be showing me and creating these graphs on your own. So I want you to give it your best shot. Tell me what you think is going to happen. Show me what you think it should kind of look like. I don't expect it to be perfect. All right. After you're done with this, that is your lesson for today. If you could upload that to Google Classroom, take a picture of it, upload it to Google Classroom, or if you're doing Notability, feel free to upload your notes there. You guys got this? Thank you for staying positive, and thank you for still working with me. I'm very excited to see what we got.